All right, guys, welcome to lesson 6.7. Here we're going to be talking about something called multiplicity. And then after that, we're going to actually start graphing polynomials, and we're going to spend 2 days on graphing them. Today we'll start with a slightly easier approach, and then the next lesson we'll kind of get into the final fullness of the matter. So we're talking about multiplicity and what it has to do with the graphs of polynomials, and then we're going to actually graph. So let's jump into it. So, what is multiplicity? It's the number of times that a root is repeated. So, for instance, suppose I have this polynomial right here, and I want to find the roots. Well, if you ever want to find the roots, you make the y equals 0, and then you're going to factor it, and then you set each factor equal to 0. And solve. Now, as you can see, 2 of these roots are repeated. X equals -1 is repeated twice. And so what we would say is we would say that, let me write this out here, the root x equals -1 has a multiplicity of 2, and that's because it's repeated twice. Okay, so that's what multiplicity is. Now, multiplicity actually has an effect on the graph, and we're going to look into how that is in a second. But before we do, I want you guys to be aware of something. The reason why we had 2 roots that were the same is because we had 2 factors that were the same. And since we had 2 factors that were the same, you guys agree we can write it like this, right? So if you ever have a factor with a power, that power basically is going to tell you the multiplicity of the root. So for the root -1, the multiplicity is 2 because there were 2 of those factors there. Okay? So that being said, now let's go ahead and take a look and see what the effect on the graph is. So how does multiplicity affect the graph of a polynomial? All right, well in this case, the root of this polynomial is 1. So I'm just going to go ahead and write this at the top really quick. The root is 1, so I'm going to put r equals 1. You guys agree that if I were to set x minus 1 equal to 0, I'm sorry, x minus 1 squared. If I set that equals 0, that's going to tell me the roots, right? And squared just means we have it twice. And if I set both of those equal to 0, I'm just going to get the same answer twice, right? And so as you guys can see, I've got the same root repeated twice. The root is 1 and it has a multiplicity of 2. All right, so there you have it. Now I meant to make this a -1, and I put my root, which is 1, in the middle of my table. And I want you guys to see what happens as we approach the root from the right and also from the left of that number. Okay, so let's see. Let's plug some numbers in. So let's start with 3. I'm going to plug 3 in for x. Parentheses first, followed by power, is 4. All right, let's go ahead and try again here. And now we're going to plug in 2. Why don't you guys pause the video here and plug in 2 and see what you get. And when you unpause it, you'll see the solution. All right, what you guys should have gotten there is 1. All right, now if we plug in the rest of them, if I plug in 1, I get 0. Now I want you guys to see what happens though. Something interesting happens at 0. If I plug in 0, zero minus 1 is -1, and -1 squared is 1. Didn't we already have that earlier? The 1 gets repeated there. Let's plug in -1 and see what happens now. Can you predict what's going to happen? -1 minus 1 is -2. And when you square it, you get 4, which once again is another repeat. All right, so let's graph this, and I want you guys to kind of observe what happens here, and then I'll talk about what effect multiplicity has on a graph, okay? So I'm going to plot these points. My x values need to go from -1 to 3. My y values need to go to 4. So at 3, I have a y value of 4. At 2, I have a y value of 1. At 1, I have a y value of 0. And then at 0, I have a y value of 1 again. And then at -1, I have a y value of 4. Now, if I go through and connect all these together, I want you guys to notice what happens. What happens at the root here? Well, the root was the middle. That's where it touches the x-axis, right? If you plug in a number to the right, you get 1. If you plug in a number to the left, you also get 1. Here's what happens. When you do this, by plugging in 2, I get 1 squared. And by plugging in 0, I get -1 squared. But you guys remember from a previous lesson that when you square a negative, it's the same thing as if you square the positive version of that number. So you get the same output on both sides. So whether you go to the right or to the left, both dots go in the same direction. In this case, they both go up. Okay? So same thing happens if you plug in 3. If you plug in 3, you get 2 squared. And if you plug in -1, you get -2 squared. And once again, negatives don't matter when you're squaring. So when I plugged in 3, I got 4. And when I plugged in -1, I got 4. I got the same answer for both. So what's the point of all this? That means that when you have a multiplicity of an even power, whether you go to the left or right, the same thing happens. And so let me redraw this a little bit to kind of show you what happens then in a little bit clearer of a sense. There's my root. And if I'm at the left, let's say I'm coming down, I'm gonna hit my root. But the problem is as soon as I touch that root, if my multiplicity is even, it's going to bounce off the x-axis and it's going to do the same thing on the right side that it did on the left. And so here's what I want you guys to gather from this. Even multiplicities bounce the root. It's not very good English, but there you go. So if you have an even multiplicity, then for that root, the graph is going to bounce off of the x-axis at that point, because whatever it's doing on the left, it's going to do on the right. So if it's above the x-axis on the left, it'll be above the x-axis also on the right, but it has to touch the x-axis because it's a root. So it bounces off of the x-axis. Now let's see what happens then whenever we do an odd number. So if I plug in 3, I'm going to get 3 minus 1, which is 2, and 2 to the third power is 8. If I plug in 2, 2 minus 1 is 1, raised to the third power is 1, and I'm just going to keep going here. Now when I plug in 0, 0 minus 1 is -1, and when you cube a negative, the negative doesn't go away, it's -1. Let's plug in 1. It's actually supposed to be -1, my bad. Plug in -1. -1 minus 1 is -2, and -2 to the third power is -8. So odd powers, which we talked about in a previous lesson, do not cancel out the negatives. And let's see what the result of that is. So at 3 we have positive 8. At 2 we have 1. At 1 we have 0. At 0 we have -1. And then at -1 we have -8. Now, if I go through and connect these dots, I want you guys to tell me it doesn't bounce off of the root this time. It goes through the x-axis. So here's what I want you guys to know here. Back here when we had even multiplicity and even power here, the graph will bounce off of the root. But when you have an odd multiplicity, we will go through the root. In other words, it's going to go from negative to positive, or it could go from positive to negative. But the point is that it goes through the x-axis at that point. It doesn't bounce off of it. Okay? And so that's our big conclusion there. So make sure you guys have those two statements written down. I'm not too sure if I have it on another slide. Let's see. If I don't, make sure you pause the video here and copy it down. I didn't have it written down, so make sure you guys have these written down, because this is like the main conclusion of what I wanted you guys to get today. Even multiplicities bounce off the x-axis. Odd multiplicities go through the x-axis at that value of the root. All right, so now we're going to use that fact to start graphing. Okay? Now, let me actually present this a little bit. Now, I'm not going to give you any examples with multiplicity yet, but it's actually going to be part of this problem we go through. But we're doing a bigger thing here. In this problem, we're going to graph. Okay? Now, graphing a polynomial has quite a few steps in it. And one of those steps is identifying the multiplicity and whether it bounces off the x-axis or goes through the x-axis. And we will get to that in a second. Okay? But I want to walk you guys through the entire process of how to graph a polynomial, and we'll get to the multiplicity when we get there. All right, so the first thing that we want to do is we want to set this polynomial equal to 0. And I want you guys to write this down, and as you write it down, I really want to encourage you guys to write these steps off to the side, because we're going to be having a lot of steps, and having them numbered out and written out could be very helpful. So set your equation equal to 0. The reason we want to do that is because it helps us find the roots. The next thing we want to do after that to find the roots is we want to factor it. Now, I'm going to factor it for you today, and that's what makes today's lesson a little bit less stressful than our lesson next time. Next time, you're going to have to factor it yourself. Today, I'm going to factor it for you. But if you were to factor this, that's what you would get. So step 2 is to factor it. But once again, in the lesson and also on the homework, I factor the problem for you, so that way you don't have to do that part, because that part does take some time. And this is supposed to be a 0, my bad. Okay, now the next thing that we're going to do is we're going to find the roots. And the way that you do that is by doing the 0 product property. And that's just fancy words for take each one of these factors and set them equal to 0 and solve. All right, so if I solve this first one here, dividing both sides by -3, I end up with 0. For the next one, if I add 2 on both sides, I end up with 2. And for the next one, if I minus 1 on both sides, I end up with -1. So those are my roots. That's where it touches the x-axis. So I already know something now about my polynomial. I know that it touches the x-axis at 0, at 2, and at -1. And so now I'm going to do step 4, which is where we get to talk about multiplicity. So what are the multiplicities of this root? Well, for the first root, we had 3x to the first power. Now that's an odd root. And when you have an odd root, that means we have a multiplicity of 1. And so that would be an odd multiplicity. I'll put 1 in parentheses just so we know what the power was. For the next root, 2, that one came from this factor, which has an even multiplicity, because its power was a 2. In other words, it's repeated twice. The next one doesn't have a power there, but that just means it's a 1, once again. And so for that one, we have another odd multiplicity, which is, once again, a 1 in this case. Okay? All right, now step 5 is we want to know, and by the way, here I'm just going to put even or odd. That's pretty much all we care about, is whether it's even or odd. The next thing that we're going to do is we're going to decide, does it go through or does it bounce? Does it bounce off of that root or does it go through? Well, since this is an odd multiplicity, it goes through that root. Since this is an even multiplicity, it will bounce off of that root. And since this is an odd multiplicity, it will go through the root. So I'm going to draw an arrow from here to here just so we'll know why we're saying those things. Okay? Odd goes through, even bounces. Okay, step 6 is to plug, well actually, let's say, I'm just going to say find the y-intercept, but in parentheses I'll tell you how to do that. To find the y-intercept, we plug 0 in for x, which is something we've done many times in other chapters with other functions. Anytime you want to find where it touches the y-axis, you plug 0 in for x. So let's do that. Now, this is going to be 0, this is going to be 0, and this is going to be 0, and therefore my y-intercept is 0. Done. All right. Now in the future, you don't have to show your work for this step, honestly. Everything with an x in it's just going to cancel out. And whatever, if there's a number there without an x, that's going to end up being your y-intercept because that's the only thing that doesn't cancel out. But if everything cancels out, then your answer is just 0. Okay. So, but I just wanted to show my work for that first one there. All right. So now let's go ahead and move on to step 7. All right. Step 7 is to determine the end behavior. You guys are like, holy crud, Bailey, what the heck are you doing? All this work. Yeah, there's a lot. So basically all we're doing is we're just finding out facts about what this graph looks like. We've already found out where it touches the x-axis. We found out what happens at those points. Does it go through or does it bounce? We also know now where it touches the y-axis, and now we're going to find out what happens at the left and right side of the graph. Once we know all those things, that's really enough information to turn this graph into a picture. So let's go ahead and determine our end behavior. So as you guys know from our last lesson, we need to know what happens on the right, and we need to know what happens on the left. Now, we only look at the front number, the number with the biggest power. So I'm going to put that here. And as we remember, whenever you have a negative number here and an even number here, it goes up on the left and up on the right. So they're both infinity. Now, you actually don't need to write this part to get our graph. You can. We really just want to know what the graph is going to look like. So for step 7, if you want to just draw the picture and not write the limit notation, that's totally fine. Okay? But there we have it. Okay. So that's a lot of work, but we're actually done. So let's review the steps, and then we're going to graph it. So the The first 3 steps are all about finding the roots, finding where it touches the x-axis. So first we set it equal to 0, we factor it, which I'm doing for you today, and then we set each piece equal to 0 and solve to find where the roots are. Then after that, we determine whether it bounces or goes through, and to do that you need to identify your multiplicity. After that, you find your y-intercept, and then you determine what happens on the left and right side of the graph. Once you know that, you've got enough information to graph it. Okay? So I'm going to clear my board here so I can actually graph it now. So let's go ahead and start from the beginning. This is step 8, and step 8 is to graph. All right, at the beginning, we found out what our roots were. My roots were 0, 2, and -1. Now, let me look at it again because I kind of forgot. Yeah, I was right. Okay. What we found out is that at -1 it goes through, at 0 it goes through, but at 2 it bounces. So I'm just going to write those letters there so I'll remember that when I actually get to the graph. All right, the next thing I'm going to do is I'm going to plot my y-intercept. So I've got my roots, and I determine whether they bounce or not. So that takes me from steps 1 to like 5, I think it was. Now step 6 is plot your y-intercept. Now in this case, my y-intercept is 0, and it's actually the same value as the root, so it doesn't give me another point, unfortunately, but that's okay. But you do plot your y-intercept next. So let me write some sub-steps here. Plot your roots. Determine if it's through or bounce. Do your y-intercept. And then our last step is going to be to put the end behavior on there. And what did we say happens at the end? At the ends, it goes up on the right and down on the left. So I'm going to put an arrow going up on the right and an arrow going up on the left. Now all I have to do is connect all these dots to my end behavior. So after you've done those 4 things, connect everything together, and you'll have a pretty decent looking picture. So here's what happens. My graph, starting from my left end behavior, I'm going to come through until I get to this root, and I'm going to go through the x-axis at that point. And now I see I got to swing back up and go through the x-axis again here. And then I need to come back down and hit this root, but when I do, I'm going to bounce off of that root. I'm not going to go through. And then I'm going to swing back up, and I'm going to connect my dot right there. Okay? And that's my graph. Now, we're just getting a rough idea of what these graphs look like. Okay? So, in other words, someone else might have made their graph look like this, and they would be equally right. Let me show you. A little bit different looking, right? But the point is that we have the same end behavior, we have the same roots with the same bounce and through behavior. Okay, so there you go. That's the idea. So there's a lot of steps there, 8 steps. And today, the reason why it's a little bit easier is because I'm taking one of the steps out that has the most work involved, and that's factoring. And we'll actually hit some problems up like that tomorrow, or not tomorrow, but next lesson, where you actually have to do the factoring yourself. Now, this is a guided practice, which means I'm going to encourage you guys to pause the video and do 1 step at a time. Okay? Now, I'm going to do the first 2 steps for you. The first step is to set it equal to 0. And the next step is to factor it. So I've done the first 2 steps. Now what I'm going to ask you guys to do is to do the 3rd step. So go ahead and pause the video here and do the 3rd step. And when you unpause it, you will see the solution. Okay, so that's the end of step 3, which is to find the roots. The roots are 1, -2, and +2. Now I want you guys to do step 4. So go ahead and pause the video here, look at your notes, see what, remind yourself of what step 4 was, and go ahead and do step 4 here. Step 4 was to determine what the multiplicity was. So for the x minus 1 factor, it was being squared. And so the root x equals 1 has an even multiplicity. The other two factors, x plus 2 and x minus 1, had a power of 1. So the roots that go with those, negative 2 and positive 2, will only have an odd multiplicity. Okay? And by the way, a question I kind of get asked, which I should have addressed in step 3, is, what about this guy? Don't we set this one equal to 0 and solve? And the answer is no, you don't do that because there's no x there. You can't set a number equal to 0. It has to have an x in it. So if you ever have just a number there in the front, no, you don't include that in the process of doing the zero product property. Anyway, back to our steps here. Let's pause the video here and have you guys do number 5 now. Do step 5. When you unpause the video, you'll see the solution. And there's our answer for step 5. Since we have an even multiplicity at x equals 1, we're going to bounce. And since we have an odd multiplicity at x equals negative 2, then we will go through the x-axis at x equals negative 2. And then at x equals 2, we have an odd multiplicity again, so for x equals 2, we will also go through the x-axis at that point. So that is step 5. Go ahead and pause the video here and do step 6. Now this is what you guys should have gotten for number 6. We were looking for the y-intercept. And to find the y-intercept, you plug in 0 for x into your original equation. So if you plug 0 in for x, though, all of these are just going to go to 0 and disappear, and all you're going to be left with is 8. So the answer, number 6, is simply 8. All right, last step. I want you guys to pause the video here, and I want you guys to do the last step. Now remember, for the last step, you don't need to use the actual limit notation. You can just draw the picture. So go ahead and pause the video here and draw the picture of the end behavior for step 8. All right, so what we do in step 8 is we look at the first term, and since it has a negative coefficient and an even power, we're going to go down on the left, and we're also going to go down on the right. And so that's my information. So now we're ready to graph. All right, and that's the last step. Now, for the last step, this is kind of a hard part, putting all this together, but I'll refresh your memory of how to do it. The first thing that you're going to do is you're going to go through and put all these dots on the x-axis. And then you're going to label them with a B or a T, depending on whether they bounce or go through. After that, you're going to put a dot out on the y-axis for your y-intercept, and then you're going to put your arrows on the graph on the right and left side. After that, you go ahead and connect everything together. So go ahead and pause the video here and see if you guys can sketch a pretty good representation of this graph. All right, there you guys go. The 3 dots on the x-axis are the values of your roots, 1, negative 2, and positive 2. I put a T on 2 and negative 2 because those are the ones where it goes through the x-axis, and I put a B at 1 because it bounces off of the x-axis there. I put a dot up here on the y-axis at y equals 8. We didn't get to do that step last time, but we got it here. And then I put my arrows here on the left and on the right as going down. And then starting from there, I just went up, we go through, we touch our root, we come down, we bounce, we come back down, we through, and then we go down. All right, and that would be it. So your graph should look like that. So that was a guided practice where I let you guys kind of pause the video and do each step one at a time, just in case one step was catching you, and we could just help you one step at a time. But now I want you guys to do this problem. So here's the polynomial that you're going to graph, but I've already done the first 2 steps for you. I've set it equal to 0, and I factored it. And I want you guys to pause the video here and see if you can finish the problem all the way. Take it all the way home and graph it up. Okay, there you guys go. I'll let you study that and see how it works. My only regret here is that I didn't have any examples where we had an odd power in the front. And that's a game changer. You know, if you have an odd power, instead of them both going up or going down on the right and left, you know, you could have end behavior that looks like this. But I just didn't have any examples like that today. But you'll probably see some in your homework, so just be aware it can do that. So anyway, we'll go ahead and stop there, and we'll call it a day. And we will see you guys next time, where we're going to do the same thing all over again, but this time I'm going to make you do the work to actually factor it. Okay, and that'll take some time. But other than that, we're good to go.